inverter, the peak time inverter, they have the clipping losses there. We can't be able to generate power from the clipping. So we can automatically, this power is losses from the inverter, this clipping loss. So all the inverter and based on the site location, the proper we need to select for this DC powering, the DC power of solar PV model compared with the inverter rating. So we have to minimize the clipping losses from the inverter. Normally, the Indian region and Pakistan region, we can proceed with 30% of overloading based on the inverter operating voltage. So higher voltage means we can lose for peak time. The overloading means peak time we will lose the energy from the inverter level. Okay. So now you can come to the PVsyst introductions. So I hope you know that the PVsyst software, the only used for the solar PV plant, the design and the energy estimation purpose. So here we are, the PVsyst, we can use the rooftop system, ground mounted system, and a standalone system, and the solar water pumping system. So today we are going to see only design of the ground mounted and rooftop systems. So each PVsyst software has the home window. They have the project design, preliminary design, and the project design, database, tools. So the one by one we can see and cover as well as the design point of PVsyst system. So once just the PVsyst, they have the database. You can see that the database have the weather monitoring station, the satellite data, they import in the PVsyst software. They have the PVsyst database. The database, they have the geographical site details, and the default, they have the module pan file, all module manufacturer pan file up to latest file, and the OND file for inverter. Okay, and less we can see that all the format, maybe the OND file and the module inverter, and they have the battery also is available, and the genset, we can make the genset option, and the solar water pumps, everything is available in the database. So if you don't have any OND file inbuilt the PVsyst software, we can import from the OND file from the inverter own manufacturers, and a pan file with the solar PV model manufacturer, we can import to the systems. Okay, let's come to the database. Now any project we are going to start in the PVsyst software, we have to locate the geographical locations, name and site. So where we are going to install the solar power plant, those options we need to select. There are three options available in the PVsyst. One is for, we know the latitude, longitude, and which country and area region. Everything we can able to select. Site coordinate, site altitude, everything we need to select. Another option, easiest option is interactive map. Just you know the map area of the name, just you can click. Otherwise, you go the only coordinate means latitude, longitude you have, just copy and paste in the interactive map, automatically fill all the data in the PVsyst software. So no need for any manual enter in the PVsyst software. So once you enter latitude, longitude, this automatically collect from the interactive map. They automatically fill up site name, country, region, site coordinate, site altitude, and everything will come to the database. Okay, next, so once database done, so we need to start for import from meteorological file. So meteorological file means the site, the meteorological database, they have the wind speed and the global horizontal radiation, global diffuse radiation, global film radiation, and they have the wind speed and the particular site temperature and the RH value. Everything is have the metronome weather monitoring station meteor files. So in PVsyst software, the inbuilt with the metronome 7.2, and the NASA also is there, and solar PVGS and NREL solar GS. The solar GS means the paid database. We can import from the separately. We can download from the solar GS website. We can import to the PVsyst software. That's also available in the PVsyst. So site level, do you have any measurement regarding the solar weather monitoring station? All the parameter, like I said, irradiation, temperature, and wind speed. So three parameter, hourly data, you convert to the typical monthly year TUMA data, just import to the PVsyst software, we can run the simulations. So we need to we can open the any PVsyst software. Just you can open Metronome or NASA or PVGS or NRL data. Just we can import to the PVsyst software. We can run the synthetic TMY data to the PVsyst. So as we covered the Metronome file, they have the solar radiation throughout the world, and so all the some of the regions countries they have the separate solar resource assessment unit. They have installed the meteorological mast, solar measurement mast in the throughout the country. They will measure all the parameters. They will make the TUMA data for the PVsyst purpose and other analysis purpose also. They are using the data, and the Metronome file and the solar GS and other the satellite model. So in the solar radiation resource assessment is the on-site measurement. So this is the one of the typical weather monitoring station for ground level on-site measurement. This type of instrument used in the weather monitoring station. You seen that they have the global horizontal irradiation and direct normal irradiations and diffuse horizontal irradiation, ambient temperature, wind speed and wind direction, and rain level. And this sensor, the height maximum should be 3-meter height from the ground level. So wherever we need in our weather monitoring station, and we need to measure the solar irradiation particular site, we have to install this station, and we have to measure around 1 year minimum data. So on 1 year measurement data is done. So we have to compare with and correlate with the long-term measurement data, the satellite model data. We have to measure the satellite model data. So once we did means we will get the uncertainty level less compared with the satellite data. That's only the visible for the on-site measurement. Okay, now you can see that once you import the file in the PVsyst software, we came to know that global horizontal irradiation and diffuse and all the parameters displayed in the PVsyst software. So do you have any site level measurement data? You can manually you can enter, just correct the parameters, we can import to the PVsyst software. So once they import the file, we have to save all the file into the PVsyst software, the site name and everything. So automatically the save option is available in the PVsyst. Okay, so once the Metronome file based on average daily irradiation, everything they will make it, and a synthetic file convert to the PVsyst is called a TUMA file, and finally execute for the PVsyst run applications. Okay, once our geographical location done import in the PVsyst software, so we can create the new project. New project means what type of project we are going to proceed with the for the particular location. You are going with for rooftop, you are going with for ground motor system, like that we need to define. So now we are going to select the project design. Once click the project design, we need to select for grid connected or standalone, pumping and DC grid. So your project design, you are going to grid connected means it's applicable for the rooftop and as well as ground motor systems. So once we can create the new project, make the name and what type of project we are going to provide. So we need to provide. So once enter the name, the PVsyst option will come in for save option. Just we can enter the save option in the PVsyst report. So automatically we already import the particular latitude, longitude, Metronome file, so we can import. So once done, we need to proceed with the orientation of the PVsyst. What type of orientation we need to provide. For example, we are in northern hemisphere, so our solar PV model towards to the south. So the south only will get the maximum irradiation from the sun direction throughout the day, throughout the year. So the orientation with the proper selection in our PVsyst software, they have the orientation selection is that here the orientation is we can make it for up to 180 degree. Okay, 0 to 180 degree we can make it. Here in the PVsyst software, the azimuth angle, the 0 means true south. Okay, so in our azimuth angle 0 means we consider 2 south of solar PV model. In our azimuth angles 180 means we are facing the solar PV model towards north. So minus 90 means west direction, plus 90 means east directions. So we need to select, and latitude angle also, based on the latitude angle, we need to select the plus or minus 2 degree. We can fix the tilt of the solar PV model. So we can able to screen that based on the latitude only. We can select the tilt angle. So once select the tilt angle, we can came to know that for the particular tilt position I am making the particular project, we will get that this much of energy irradiation level. So what is the optimum MMS tilt angle position? We get the maximum irradiation fall on the PV model. Those points we need to consider from the any design of solar PV model. This one applicable for the ground mounted system. Suppose in this case you are going with for rooftop system, just you can select what is the roof slope. Its slope should be 5 degree, and what is the azimuth angle directions. As I said that the building slope towards to east, we have to put for minus 90 degree for the set azimuth angle. So this is considered to the east direction of the set. And tilt angle is 5 degree or 12 degree set slope. We have to enter in the these options, the orientation option. So once the orientation done, so we need to know that the detail losses. Detail losses mean in our PVsyst design we have to enter the losses means the solar PV model cable losses there. TC cable. TC cable means solar PV model to Stinger emitter box and Stinger emitter box to inverter. Okay, this is for ground mounted project. So TC cable is the two places where used in the ground mounted project. So solar PV module to Stinger emitter box and Stinger emitter box to inverter. The DC losses, this is the OTC ohmic losses. Okay. Another one is for AC ohmic losses. AC ohmic losses should be after inverter to the grid injection point, the pooling substation point. We have to consider. So, and as well as the plant has auxiliary power consumption and light induced degradation abate, mismatch loss, soiling loss, IMA loss, aging factor, and thermal parameter. Thermal parameter means we are going to put for the solar PV model open on the ground, fully circulated air, or metal roof on the metal roof, or insulated with the metal roof. Everything we need to consider. The losses we need to consider the all the solar PV ground mounted as well as the rooftop solar PV systems. Okay. Okay, I said that this is the TC ohmic losses. The total loss of from inverter to solar PV, not inverter, solar PV module to inverter. This losses maximum 1.5, not 3%. I here wrongly mentioned 3%. It should be 1.5%. 1.5%. Some of the tender, the government tender, they clearly mentioned the rooftop system or ground mounted system. They will allow for 3%. As per the tender specification, we need to proceed 3%. Beyond the 3%, they will make the penalty to us. So next slide, I'm moving. Yeah. So once the PVC is done, also the enter the losses. We came to now voltage drop. Enter the losses we done. We can able to see that. We can able to see the wiring diagram. What combination we prepared, the string combination, everything we came to know that. So how many azimuth angle, what is the string combinations and voltage drop, everything we came to know that. So this is for incident angle modifier. This is one of the losses. The solar PV model placed on some tilt angle. The sun position take a sun hours changing for the angles. So some of the all the radiation not hit on the solar PV model. Okay. Some of the radiation fall under away from the solar PV surface. So reflection. This is called some of the losses happen. So this is called incident angle modifier. So they have the ASAIR model and AR coating model is available in the PVsyst software. So we can select one. Maybe you know that we can familiar with the OEM solar PV model manufacturer. They will share the what their incident angle modifier for the solar PV model. So those value we can enter in the IMA factor. So this is a aging factor. So this is aging factor used for the. So now we are running the new solar PV plant. Aging factor should be 1. Suppose you are running the 5 years or 10 years old plant means, for example, 5 years old plant you are running the PV system. We want the PV system report. We have to make it for aging factor 5 years, and per annual degradation second year onwards, the annual degradation should be 0.4 percentage. So 0.4 to 0.6 percentage based on the solar PV model. So we have to enter. We will get the use degradation up to 25 years. Remaining years also we can be able to consider what is the degradation level getting from the first year to 25 years, or 5 years to 25 years. How much energy will get it based on the customized aging factor we have to enter. We have to enter and we can be able to get it that our aging parameters. Now we come to the coming to the overall losses and ground mounted rooftop system. Now you can see that the thermal loss coefficient, the ground mounted system should be 20 watts per meter square. It means they have the losses less. They have the, because of the ground mounted system solar PV model surrounded by air, the elevated from the ground. So the watts should be considered 29 watts per meter square. Suppose in a rooftop system also you are going to consider RCC roof, you are going to put in the MMS structure. On the MMS structure, you are going to put in the solar PV model. We have to consider 29 watts per meter square, the thermal loss coefficient value. Same rooftop system, you are going to fix the metal roof. The metal roof and the solar PV model cap should be 100 mm minimum. In this scenario, we have to select 15 watts per meter square, the thermal loss considered. The integration and for the building integrated solar PV model, the no gap between the metal body or any building that's directly placed on the solar PV model. Those scenario, the building integrated solar PV model means we have to consider 10 watts per meter square. Okay, as per our industrial experience, the TC ohmic losses in string inverter, because of string inverter means no need for string combined box. The solar PV model output, the string power, the directly given to the string inverter, no need for any string combined box. So those scenario, the string inverter voltage drop should be 0.8 percentage. So same Stacy volt ohmic losses central inverter. The central inverter, I already said that the central inverter using mean we have model to string combined box to inverter. So those ohmic losses would be 1%. Okay. So coming to the AC ohmic losses, the string inverter is 1% because of after a string inverter, the AC cable is going to the ACDB, AC collection point distribution board and transformer, everything will going. Those scenario we need to consider 1%. For central inverter, they're directly going to the IDT, the power transformer. So the voltage drop should be 0.6% AC ohmic process. Okay. So in our solar power plant, rooftop ground mounted and the big large size of rooftop also, they need the thermal transformer. So those scenario we need to consider transformer losses should be 1.1%. Okay, for the constant and load losses we have to consider 1.1%, and string voltage and string voltage mismatch losses should be considered 0.5%, because of we are using multiple number of solar PV model. Each model does not have the same current and voltage level. Some mismatch losses or circulating current will happen. Losses will occur in the internal the model itself. So we have to consider 0.5% of the mismatch losses, and the soiling losses we have to consider 2%. 2% means it's not a desert region. Normal any land slope terrain or any moderate slope terrain, those region we have to consider 2% of the soiling losses. Soiling means how many percentage of soiling test accommodated on the solar PV surface. So what is the cycle required for cleaning the module? those factor we need to consider the soiling factor 2% for PVsyst. Nowadays, one more equipment available in the market, the Test IQ, the manufactured by the Caponshon instrument manufacturer. So we will install the Test IQ in the any solar PV model. We can estimate we have to consider 2% or 3% on particular project designs. We can easily estimate the test how much soiling factor we need to consider. So those option also instrument also available in the market. And as I said that light LED losses mean light induced degradation. It should be 1 percentage. The as per the latest technology for O&M and data sheet we have to refer. The minimum is 1.5%. So those end of the first year, it will happen for 1.5%. Second year onwards, it should be 0.4%, 0.4 to 0.6% based on the solar PV model OEM recommendations. Okay, and model quality losses mean nowadays all the solar PV model, it is not a losses came from the model manufacturers. Nowadays all the solar PV model manufacturing for positive tolerance of the solar PV model. Suppose my solar PV model is 540 mono per 144 cell, the positive tolerance is 0. Plant availability, unavailability losses. So we have the solar power plant and the ground mounted rooftop. We have to consider the grid unavailability, the plant internal. There have some breakdown issues happening throughout the year. So we have to consider 1.5% the plant unavailability. It should be the rate days should be 3.65 days throughout the year. So those year we need to maintain activity, some preventive maintenance, precautions maintenance, those activity we need to consider at the plant level. So auxiliary power means we have to consider ground mounted projects, 4 kilowatt, 4 watt per kilowatt power we have to consider. In a rooftop, no need for any auxiliary power because of ground mounted project only auxiliary power mean we have to use for in a pooling substation. The pooling substation they have the UPS power system, and the plant level they have the peripheral lighting, and as well as for the inverter room, MCR room, they have the install the nighttime power consumption. So we have to consider 4 watt per kilowatt capacity we need to consider. And the spectrum correction losses mean these losses given by the solar PV model manufacturer. The particular that we are using the source model, what is the spectrum is we need to consider. These losses should be 0.5%. The spectrum correction loss recently only the PVsyst software implemented the software. Previously, the manually we will estimate it from the PVsyst. Now the inbuilt this option is enabled with the PVsyst. So this is for Harrison 5. So once our location, based on the location, we are proposing the solar PV module on the rooftop or ground mounted. So nearby any shadow is there throughout the year. What is the shadow fall on the solar PV panel? How much, what time you will follow? Though all the expert we can came to know from the PVsyst. This option is available. We need to use for shadow screen option. So we can create a entire solar PV model plan or rooftop system in the 3D model. So one more option is available in the we have used for AutoCAD file. The AutoCAD file they directly import to the PVsyst for 3D model, 3D structure, and in 3D structure we can import to the PVsyst. We can run our simulation. We can get the power. We can get the energy numbers. Same another software for Google SketchUp. Google SketchUp along with for Skeleton model. So we can draw the entire solar PV model along with the obstacles. Once a school setup is clear model done, we can directly import the file to the 3D file into the PVsyst software. Just we can run, and we can get to know that how much shadow losses will happen. Its shadow screen, everything we can estimate in the horizon file. So, once done the horizon file, we need to enter what is the project proposed capacity. So, in the solar PV model, how many number of you are going to connect, and what are the string combinations, which inverter we are need to select. All the expense we need to enter in the PVsyst. The system sizing is there. The system sizing we can able to click, and the system sizing we can able to see means they have we have to enter the proposed the system capacity. It means 100 kilowatt to whatever we need the kilowatt range we have to enter. And once system size is defined, so number of systems, suppose we are going for rooftop system, the multiple number of string inverter subsystem also we can enable in option is available in the PVsyst. And once the option is available, and once module also we can available, so module we can able to default module manufacturer, they are given all the module manufacturing in the PVsyst software. So we can select what type of module we are going to use this project, what's the voltage, everything we need to consider. So once select the model, we have to select for inverter, which type of inverter, and what type of inverter model, what is the inverter voltage, the input voltage, then what is the MPPT, maximum power point, or operating voltage, all the parameters we need to select for system sizing. Once system sizing is done, so and based on the temperature collections, the PVsyst is itself the default how many number of string we can able to maximum allowable. They given the range will come, so we can select for 1000 volt, 1500 volt system. We can able to see around 28 model connected in series or 27 model connected in series particular region. We can able to select. So once done, we can proceed with for already entered for TT losses and everything. We can proceed with for run simulations. Once complete the all the analysis, system orientation parameter, and as well as system parameter, as well as the TT losses parameter, everything done in the PVsyst software, we have to proceed with simulation. Once all the parameters enter in the simulation, just we can enter the ready for the simulation. Okay, so once enter, we can came to know that how much of energy we'll get it from the PVsyst. This is our PVsyst software output. The PDF file, you can see that this is our PDF file. So this is a PDF file, we can get it from the PVsyst. So once run simulation done, we came to know the result. The result, they have the main page, they have the about the site information, where we are sited the proposal, what are the site latitude, longitude, and what are the tilt angle we proposed, was it the Smith angle, what type of module and which angle we consider, and what type of inverter, how many module connected in series, total number of module, number of inverter, all the parameters displayed in the first or second pages. And and the third pages we came to know that our input losses, how many input losses, DC ohmic losses in percentage, and all the losses whatever you enter in the PVsyst software, they came to summarize this much of losses we considered in the percentage. That's also we can display in the PVsyst software. This is for once the shadow screen. Based on the shadow screen, shadow region, how many, what is the alpha losses will happen. Those also displayed in the our PVsyst software. The report we came to know that, and finally the PVsyst software, they have the annual generation, how much month wise, how much energy generation, and what is the irradiation losses, what are the other losses in the graphical form, as well as the tabular form. We will get it month wise performance ratio, month wise what is the energy injected in the grid, all the parameter. So after simulating the loss diagram, the Sangeet diagram, normally called for Sangeet diagram. Sangeet diagram means the overall losses, how much energy will get it from the sun, the particular latitude, longitude, what are the losses expected in the particular project. So major losses in the temperature losses, because of based on the temperature only our losses will going down. For the ground mounted project, around 9 to 10% we had the temperature losses. In a rooftop project, we go up to 12 to 14% based on the rooftop projects. Okay, so all the losses we came to know what is the percentage. For the Sangeet diagram, we came to know that what is the final output in numbers. Normally, 1 megawatt solar PV plant lacks energy generation per annum coming around 12 to 14 lakhs for South Asia region. Yeah, and come to the result analysis. This is I already told that we get for 25 years aging factor. So up to 25 years, the end of the first year we get it for 1.5% aging factor. Another one is for the uh, second year onwards, we'll get it for 0.4% day by day. The losses will occur in the PVsyst. So up to 25 years, we can able to estimate the solar PV plant, what is the PR value, what is the energy numbers. Up to 25 years, we can able to estimate in the PVsyst software. Yeah. So coming to the probability factor, probability means suppose we are going to consider bank or any investing bank, they will consider for uncertain level, because of we are considering with for theoretical value. So we need to consider P50 or P75, P90. They have the uncertainty level happen, losses will happen because of meteorological file also not a standard value. Some future, some of the uncertainty value will error will happen. So we need to consider uncertainty value up to 2.5%. So based on the 2.5%, we will estimate the value of P50 value. P50 value means probability of 50. So 50%, we should get the energy changes from the number from this plant. This means 50% probability, 50-50. P75 means probability of 75 means 25%. We should minimum get the energy from this plant. 75% probability. P90 means in this plant 10% we get the minimum generation output from the number. 90% probability not there. So all the investor, they will select P70 or P90 value, not for P50 value. They will make it for minimum risk to the project. They will consider only P75 or P90 value. Whatever the banker and investor and developer combined, they will consider with the P75, P50, P90 value. But always we are all the EPC engineering procurement consulting agents, they will going to match with for P50 value. So once they have done the PVsyst report for rooftop any ground project, we came to know that what are the parameters consider, what are the cable size, what type of inverter, everything we need to taking care of the account. So once the project based on the result we implemented site, next turn means we came to know that this much of energy will get it from the site. So this much of investment will need. So they will implement the project. So next come to the performance assessment. As of now, we seen that what are the parameter we need to select. We need to select for the rooftop and ground project design expert. Now the project is already commissioned. The commissioned project, what are the validation, the performance assessment, what is the performance assessment we are going to done based on the PVsyst and actual data available. This is applicable for the ground mounted rooftop projects. Suppose our plant is 5-year-old plants. Okay? So 5 years old plant means the plant was commissioned in the year of 2017. We have to collect site operational data, daily, monthly, yearly energy generation data from the SCADA system. The SCADA system will measure all the parameters from the all the parameters from the rooftop. Just a minute. And weather monitoring system. So weather monitoring system, each site, maybe rooftop system as well as ground mounted system, they have the weather monitoring station. we have to use it. So weather monitoring system we have to use, and the weather monitoring system, as I said, that they have the global horizontal data and the global tilt angle irradiation and plane of array and atmospheric temperature as well as model temperature. We have to collect from the site level, and to soiling factor estimation, how many soiling pattern at the particular site, we have to select the model cycling estimation and forecasting data. So once all the data done, so we have to run the all the simulation. The same time we have to consider the what's the actual the design parameter of DC voltage drop and AC voltage drop. Those value also we need to consider. Again we run the PVsyst report. So 5 years old mean, so up to again 20 years, what is the energy generation value from P50, P75 and P90 value with all uncertainty value. So those here we need to consider the site level weather monitoring station and the correlation with the actual energy generation. We compared with the estimated generation, we came to know the PVsyst, but one value we have and another value we get it from the actual generation. This is our PVsyst report, and the actual is the how much we are getting for last year. Those actual generation we need to make the comparison. So here I'm going to explain one more sheet. You can see that sample summary sheet of operational production estimation. The project is 2017 year old plan. So this plan we collected from the all the data from monthly and daily, yearly wage generation data, and we compared with the old PVsyst report. Again, we did the analysis. Okay, we estimated the you can see that the project sheet we have to estimate the plant historical summary, what is the DC capacity, AC capacity, as well as our project. All the information is need to enter in the summary sheet. So the result once done, we have to run the long-term correlation parameter, annual degradation estimation, and some the plant has some curtailment. Look, curtailment means we have the generation power, but we can able to inject the grid. That's the curtailment. The curtailment also we can able to consider in the operational performance assessment part of view. So once everything entered the calculations, once PVsyst run, the PVsyst value they enter into the our own Excel format of tool X. So we came to know the what is the next year the sheet from the PVsyst. Now you can see that. So here we consider future energy index. The plant is around 3 years old plan. So we consider about 1 year, the from starting from 2020, so up to the 2041. So you can see that what is the uncertainty level we consider, what is the, so we need to mention what is the uncertainty level is 1%, 3%. So all the expert we need to enter. So once you enter mean we came to know that the project is working well or not. So what is the performance wise, what is the next future wise forecasting of energy, how we'll get it from this project. So all the expert we came to know once using the performance assessment from the actual data collected from the site. So once this report is ready, so for example, any buyer, any solar power plant buyer, they want purchase the solar power plant from the seller. They collect all the data for SCADA data, including weather monitoring data. They will share, and we do the analysis. The project is viable or not, up to the future, how much energy will get it, what is the investment period, everything we can able to calculate. So based on this operational energy estimation by using the PVsyst software. So based on this sheet only, the year-wise next upcoming year-wise how much energy will get it from the particular plant. So this much of energy will get it mean the project is this much of viable for the buyer, the banker. They came to know that. This is one of the method we are using nowadays in all the industries. Any banker and investor, they based on the operational energy production estimation sheet by using the PVsyst and the internal tool. We came to know that the project viability and all the aspect we came to know the numbers only they want for the next years onward, how much energy will credit from the particular project, installed project. So based on the only they will do the invest they will invest the plant or not. We came to know that. Uh, yeah, and next you can see that. So as of now, I covered for the solar power plant. What is the use of the solar power plant and everything. So now you can. Do you have any questions? Please let me know. We have the questions.
Now we will move towards question answer session. Is there any questions from the attendees?
Please ask any questions. Otherwise, I will not cover anything else. Otherwise, I feel that. If you have any question, please chat the chat box. You can give our questions. Maybe I will read. I will one by one. I will explain.
I hope there are no questions. Thank you so much, sir, for your such a precious time.
Thank you, ma'am. Thank you all. Thank you all.
Hope that all of us will be staying safe, happy, and healthy. Take care of yourself. Allah Hafiz.